Hello, this is Daniel Levin with the camera. This is Ikea. This is Zoe, and this is our 211 traffic light circuit. Now we had to use 5 boards because this is a very large circuit, and the way the circuit actually flows, it flows with the light. So there will be 24 LEDs representing the 24 light changes on the 8 different lights. Okay, we started from this 3-lane intersection from East 33rd, and we start with all these being green. And if all these are green, everything else is red. The LEDs are not working at the moment, but the circuit does. Now when all these are green, everything else is red. When this left turn lane turns yellow, everything else stays exactly the same. These two are green, everything else is red. When this one turns red, these two stay green, but Lake Drive is now green, allowing traffic to flow from there and these 2 lanes here to continue flowing. When that light turns yellow, everything else stays exactly the same. Red, 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 green, green. With this light turns yellow corresponding with this light here. So this also turns yellow. Now when they both turn red, this one turns green, this one stays green on the far right, and everything else stays red. They turn yellow with each other and eventually turning red. When they both turn red, these 2 lights over here turn green, this light over here stays red. Now when this light, the turn lane, will turn yellow, everything else stays the same. Red, 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 red. And this one here stays green. Now when this one turns red, this one stays green, this one over here turns green, going from north to south and south to north, both stay green, everything else turns red, and then they both turn yellow, eventually both turning red, and then that will restart the cycle with everything being red except these 3 here being green. Now we built this circuit by using a counter. We use the decoder, a 4x16 decoder that leads into 3 NAND gates. And from the NAND gates, we lead into the flip-flops, which all eventually lead back into the decoder, which is basically our counter, which is going to go through our states. That is right here. As you can see, the decoder. You have 4 NAND gates, representing for ABCD. Flip-flops right here, which all lead back into the decoder right here. And that is basically our counter. Now, we started off with the first light here, and it's on a different count right here. Well, it's following the count right now. So this is our state diagram right here, which represents every one of the lights changing to the next light. Now, these are all basically the ones on our truth table. So for 0000, we started here, which is going to show 0000 here, and this is our first light. First light, and we have 8 of them. Well, 10 states of the light. So you have 10 different rows with 8 different lights. So it's going to show each of the states. So it's going to go for the first red light. It'll go for the 8 lights. Excuse me. It'll go red, 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 green, 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 red, red. As you can see here, red, 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 green, 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 red, red. And this corresponds for all 10 states for all 8 lights.